So this one's going to look a little bit different to you guys in terms of the recording because I'm going to be flipping back and forth between Desmos.com. And if you want to look at any of these videos or manipulate any of the stuff I'm doing on Desmos.com, you can just shoot me an email and I'll share the link with my graphs that I'm working with so that you can kind of play with the slide bar a little bit and see what you think about it. So 3.4 is going to be on rational functions, which we've done, and it's one of those things that you guys tend to struggle with, not necessarily the idea of the fact that it's a reciprocal, but the key features that make up a rational function, which are like our asymptotes, both vertical and horizontal, as well as our shifts. So we're going to review just briefly what the ideas are of reciprocal functions, and then we're going to play a little bit with Desmos.com, and again, you can email me if you want to play with the graph too and see what you want to do. So let's say I have a linear equation, y equals x. It's really straightforward, right? Y equals x. Okay, so let's say I want to look at the reciprocal function of y equals x. Well, if I were to plug in x, our original x, my output becomes 1 over x. That's y. So each one of these terms becomes a reciprocal. So 1 over 1 becomes 1 over 1. Well, that's easy. 3, 3 becomes 3 1/3. 4, 4, 5, 5, 6, 6, 7, 7. I'm starting to go up here, and let's say I'm at 10, 10. Well, 10, 10 then becomes 10, 1 over 10. So every time I take a step further up here, I'm getting closer and closer and closer to 1 over infinity, 1 over a million, 1 over a billion, whatever the case may be. So I'm getting really close to 0 going this way. That's a horizontal asymptote for this. Now, this way, let's say I put in, looking at like this point, we're going to do a little zoom in there and say I'm looking at the point 1/10, 1/10. Well, when I change that into its opposite, 1/10, 1/10 becomes 1/10, and then this becomes a reciprocal, 10. So when I plot 1/10, it's way up here. When I plot an input of 1/100th, it becomes 100. When I go 1/1,000,000th, it becomes 1,000,000. So the closer and closer and closer I get to 0, the closer this is going to get to positive infinity. So that's going to be our vertical asymptote. The other thing to recognize here is that if I have an x in the denominator, just x, I can't have 0 in the denominator. That's the other reason we're getting a vertical asymptote right here. If you came at it from the other side and you plugged in -1/2, you'd get -2, or -1/1,000,000th, you would get -1,000,000. So you're going to get that going all the way down. And then this way, same kind of deal as we were looking at here. Now, here's another one. Let's say I have 0, 0. Well, 0, oops, you can't put 0 in the denominator, so we've got our little asymptote here. Let's say I'm looking at 1, 1. Well, the reciprocal of 1 is just 1, so you'll always tend to see, so long as 1, 1 exists on the original function, that these two functions will meet if I were to overlay them at 1, 1. Okay. Here's the other one. If I did 2, 4 here, I'm going to get 2, 1/4. Let's bop over and look at Desmos so that we can kind of start to tinker with these a little and look at the big ideas. So same thing, if I were to plug in -10 here, my output of -10 would be positive 100, way up there. So here, -10 is going to output 1/100th. Whoa, that's even closer. So this is going to be approaching our asymptote even closer or faster than this one was. Just like the growth rate here gets faster as this goes on and on and on, it's getting steeper and steeper and steeper. This is getting closer and closer to the output of 0. Transformations, we'll look at these in a minute after we've looked at decimals. So hold on here for just a second. And let's look at graphing linear functions. Okay, again, if you want me to share this with you, I can. So our original function here, let's is sum, or down here. We're looking at this some linear function mx plus b. Okay, let's just let 0 be our y-intercept so that we know what we're looking for. As this slope becomes negative, the outputs are also negative. So if this is 5, I don't know, negative 5 or whatever the case may be, the output is also going to be negative in the reciprocal. The fact that it's a reciprocal doesn't change the output to be positive or negative. It still say it's in the same place, positive or negative, as the original function would have been. Okay. Now let's look at what happens when let's make this a friendly number, like 1 or something like that. Let's look at what happens when we add in a transformation in the denominator. Let's say it's minus 5. So you might be thinking, well, minus 5 this way, but you can also think about it as a transformation horizontally, where you could be looking at this kind of thing, right, where you have a horizontal shift of negative 5, which means the opposite, moving it to positive 5. So if you think of it that way, you can see a little bit clearer why our rational function is moving left and right. Okay. So let's hide this guy. Let's look at one that's quadratic. So like this one right here. Whoop, I was going to hide his one over that. So here we have a quadratic, and let's just let it be this simple little parent quadratic. So that would make our two roots a double root, or roots that are equal. It depends on how you want to talk about it. Being so here's our parent function. Now I'm going to write g of x as, so that we clearly remember what it is, 1 over f of x. And then we're going to graph it. So there it is in orange right there. Where's that guy? So when I adjust these here, you're going to see the corresponding adjustment in the reciprocal function. So look what happens when I move this left or right. Well, that little u thing shows up. I'm going to make it really big, like that. And then we'll just keep that friendly. We'll just make the 1. So whatever my two roots are, my horizontal roots, those are going to give us our vertical asymptotes, because when our original function crosses the x-axis, I get an output of 0 as my total value of this, which means that my output f of x, the output of the total function, is now 1 over 0. Hey, we can't do that. We can't do 1 over 0. That's why you're going to get a asymptote, a vertical asymptote, whenever you see these terms being equal to 0, or anytime you see the denominator being equal to 0. So watch out for that. Again, if you were to zoom in here, you would see that our functions are meeting at 1 when the output of the functions is 1. See, there they are meeting where the outputs of the functions are 1. there, and there again, -1. It's because 1, when you take the output of 1 and you make a reciprocal of it, 1 turned into a reciprocal is just 1. So if you're ever looking for a quick way to graph the reciprocal of a function, you can use that as one of your features. The other thing we can see here is that as this graph, I was going to grab it and move it. As this graph moves down like this, you can see that this guy is getting a shallower and shallower curve there. And the reason that happens is because all of these values right here for y, so 5, 10, -15, -16, back up, these all become 1 over -5, 1 over -10, 1 over -16. So all of the values from 1, -1, down to however far it has to go now need to be compressed between -1 and 0, right there. Okay. Let's look at, I want to look at horizontal asymptotes really quick. Let's hide some of these. We'll look quickly at horizontal.